One of the big things that has confused people was a better understanding of Earth's magnetic field. So again, it's being generated somehow, right? There's a few different ideas, but somehow it's being generated within the Earth. And then a lot of it will attenuate in the mantle because of the mineralogical composition and it's hot and everything. So because it's superconductive. The entire mantle of the Earth is superconductive. Not superconductive like the technical definition, but just very conductive. So it will absorb a lot of that magnetic field because anything that's conductive will absorb the magnetic field. So like they say like maybe 1% of the field strength leaks out of the interior of the Earth. And that's what we get at the surface that extends out to space. And then they talk about the inverse square law, right? People are like, okay, well, via the inverse square law, this is how much it decays. If you double the distance, it goes down by 4, right? That type of deal. But magnetic fields are also generated all over the planet. We have magnetic fields being generated from electric currents within the mantle and the crust, deeper down. So we can't think about Earth's magnetic field just as it being created in the core. It's really what is the amalgam magnetic field across all scales of Earth, and how is that influencing any single point that you are at, whether that's on the surface, whether that's, let's say, 100 kilometers down, if you have this special spaceship, whether it's up in space. Because if we go up to the ionosphere, the uppermost part of the atmosphere starts about 50 kilometers up during daytime, more like 100 kilometers up at nighttime. There are powerful electric currents that flow in the ionosphere that create magnetic fields. And so the magnetic field of the Earth is heavily influenced by what's happening in the ionosphere in that zone, because there is that inverse square law. And you're not having any electric currents in the atmosphere for the most part because it's very resistive. So what we get at the surface basically does decay with the inverse square law just out to the ionosphere. And so the field strength does go down quite a bit. But then these electric currents in the ionosphere are quite powerful. And so they can really add or subtract to that magnetic field. And then if there's a solar maximum and these ionosphere currents are a lot stronger, now our understanding of Earth's magnetic field is a lot more dynamic. And you can't just look at it from a perspective of, oh, that's the dipole strength and it's going down. It's like, no, we have really dynamic processes happening in our upper atmosphere and in our plazosphere influencing the magnetic field there. And so it's this piece of like poor understanding. People that report this just simply don't understand what they're talking about. They launched these satellites, these swarm satellites in like 2014. And so they finally were able to measure Earth's magnetic field in a very high resolution way. And this was at the tail end, starting to become the tail end of solar cycle 24 maximum. And well, they noticed that the magnetic field strength in the ionosphere where these satellites are was decreasing. And so this initial story came out with the first 6 months of data that Earth's magnetic field strength was decaying like 10 times faster than normal. Once they had a bit more data, they realized, oh, that's actually not the case. It's because there's also seasonal effects, right? There's solar cycle effects. So it wasn't Earth's dipole strength. They were measuring magnetic field changes as generated in situ by the ionosphere, coupled with the longer term stability of Earth's magnetic field, which is undergoing a very slow decrease in dipole strength, but not at a rate that's alarming. But up in the ionosphere, up in the plazosphere, it can be very dynamic and it can change on timescales that are more human. If you look at just that data, you may think, we're doomed, it's happening, but it's actually maybe just the solar cycle expressing itself. And it's the first time we ever made these observations, and therefore the first time we've now understood that this is the case. So that's the whole story there.